Hello. So today we are introducing a new theorem and a way to completely solve almost any factorable polynomial. So before we were getting polynomials with a factor known, where the factor was given to us, or it had a greatest common factor, or you could factor by grouping, or it turned into a quadratic and then you would use the Xbox method. But there are polynomials that none of those approaches will help us with. Like if we have x to the fifth and there's no greatest common factor. Our method today is going to help us solve any polynomial, and we're going to use a theorem and synthetic division. Okay, so solving any polynomial. And so our theorem is the rational root theorem. And we're going to write the technical definition, and then we'll explain it, and then go through some steps of how to use it with an example, and then do a couple more examples. Okay, so this rational root theorem says if f of x, and here's f of x, some number at the beginning of the function times x to the nth power, so some degree, it could be big, it could be small, plus, and then, a bunch of function stuff, plus our second last term, plus the constant. So here's our polynomial, could be anything, has integer, like that, coefficients. So if all these a values here are integers, not fractions, not irrational numbers, then every rational solution of f of x equals 0. So all the roots, all the solutions have the following form. Oh, whoops, there we go. So as long as the numbers in front of the x's, as long as the coefficients are integers, positive or negative, but no fractions or irrational numbers, then every solution has the following form: P over Q. And P and Q are just going to be some numbers that are determined by these two things. Factor of constant term a sub 0 divided by factor of leading term a sub n. So what that means is this first number and this last number, we're going to take all the factors, all the numbers that multiply to make these two things, and divide the last number's factors by the first number's factors. And those are all of the possible solutions. It's going to give us a list, a long list of numbers that might include fractions that could be the solutions. And then we're just going to take that list and check them. So it doesn't tell you all the actual solutions. It's just going to give you a list of possible values that could be the solutions. And then we have to check, which ones of those are actually solutions. Okay, so we're just going to do this by example. Find all solutions of x cubed minus 8x squared plus 11x plus 20 equals 0. Find all solutions of x cubed minus 8x squared plus 11x plus a 20. Now, this is not easily factorable. There's no greatest common factor. Factoring by grouping isn't going to do anything because we can factor out this x squared, but then there's nothing to factor out here, and so there's no factoring by grouping. It's a cubic function, so the Xbox method isn't going to do anything either. So the way to do this, step 1, is going to be just list all of the possible solutions using P and Q. All combinations. All possible combinations. Okay. So P is all the last numbers. So from this 20, P is the factors of 20, this last number. And Q is the factors of 1, this front number, the leading coefficient. Okay, and so to find all of the possible P over Q solutions, X is going to be P over Q, and we're just going to list them all out. So they're all going to be plus or minus because the factors could be positive or negative. We don't know. They're all going to be plus or minus. And then we're just going to go through dividing the numbers that multiply to make 20 by the numbers that multiply to make 1. This first one's a little bit easy because all the numbers that multiply to make 1 are just 1. But we still need to list out all the numbers that multiply to make 20. You can go biggest to smallest. It doesn't really matter. My suggestion is to start with all the small numbers. Because when we guess and check them using synthetic division, and I'm going to run out of room for sure, the small numbers are a little more likely to be factors than the big numbers. Not impossible, just more likely. So numbers that multiply to make 20 are 1 and 20, so 1 over 1. I can divide 20 by 2, so plus or minus 2 over 1. I can divide 20, I can't divide it by 3, that'd be the next number in line. But I can divide it by 4, so plus or minus 4. And then I can divide it by 5, plus or minus 5 over 1. 6, 7, 8, 9, 10. And then plus or minus 20 over 1. So all of the rational roots, all of the solutions that make this function 0 are here. Now, these are not all the answers. Some of them are wrong. Some of them, if you substitute them in, you get not 0, you get something else. But the 3 solutions, right, this is degree 3, so there's 3 solutions. The 3 solutions that are solutions for that function are somewhere hidden in here. So our step 2, now that we listed them all out, all the factors of the constant at the end divided by the factors of the constant at the front. Step 2 is just check them, test and check using synthetic division. Test and check using synthetic division. So I'm clearly going to run a room here, but we're just going to go through these numbers and we're going to get rid of all the divide by ones because these are just integers. We're just going to check synthetic division and see, do we get 0 at the end? Which is what we did last week. Check if we get 0. If we get 0, it is a factor, and then we can factor the problem and find the other solutions more easily. Okay. Sometimes this takes a long time because we're going to check them until we find one, and we might not find one in these first few. I really suggest starting with the small numbers, but you can start with 20 if you want. You can start at this end and work this way. You can start at this end and work through the numbers this way. So my coefficients for synthetic division are 1, -8, 11, and 20. And so I'm just going to check them in order. 1 first, and we just do our synthetic division. We're going to add down and multiply diagonally. So I add 1 to 0, I get 1, times 1, I get 1. We get -7 times 1. -7 gives me a 4 times 1, 4, 24. This is not 0, which means it's not a solution. So then we just go to the next number. We didn't get 0 in the end, so when we divided by x minus 1, we got not a 0, so there was a remainder, so that means it's not a factor. So then we just check the next one. The next one is going to be -1. Into 1, -8, 11, and 20. So our goal is to get 0. I'm going to add down, multiply, we get -1, add those, we get -9, add those, we get, add those, multiply, we get +9, add, we get 20, multiply, we get -20, and then we get 0. 20 minus 20 is 0. So that means is a 0. So -1 is a solution. -1 is a solution. We got 0. So it is a factor. Thankfully, it was in the first set. Sometimes it won't be. Sometimes you'll have to do like 5 of these synthetic division things till you find a 0. And sometimes there'll be double roots. And so you'll have done -1 and say, oh, I'm done. I found it. But then you're like, how do I factor this further? And it's -1 again. So, yeah. So we're not done. We found one solution. There are 3 because it's x cubed. It's a 3-degree function. And so we found one of our solutions. We need to find the other 2. Now, we could just keep checking with synthetic division until we found them all. That's a way to do this. You can just go through the list. We checked both +1 and -1. You can just check +1, -2. See if you get 0. Check 4, check 5, check 10, check 20 until you found 3. That's a way to do it. That is not how I would do it. Since we found a solution here, and this becomes our quadratic factor, let's just factor this, and then that will give us our 2 solutions. So once you found a solution, use that solution to factor the problem, and then either do the whole process again, or use one of our other tools like factoring by grouping or the Xbox method for quadratics. Okay, so what we're going to do is we're going to finish factoring this. So we're going to use the result found. In this case, it was -1 to completely factor and solve. So we found -1 as a solution, which means we can factor out x plus 1, and we use the values from our synthetic division here, the 1, the -9, and the 20, to give ourselves x squared minus 9x plus a 20, and this equals 0. So we factored out the x plus 1 because -1 was a solution. So when we substitute that into here, we get 0, which is here. So now we just need to factor this x squared minus 9x plus a 20. And so this is a quadratic, so we would use the xbox method. A is 1, B is -9 from here, C is 20. We need two numbers that multiply to make 20 and add to make -9. So that's going to be a 4 and a 5. Add to make 9, and then they're both negative. Still multiply to make a positive number, but they add to make this negative number. And so this x plus 1 times x squared minus 9x plus 20 becomes x plus 1, x minus 4, x minus 5 equals 0. So which means the solutions are x equals -1, x equals 4, x equals 5, which gives us the coordinate points -1, 0, 4, 0, and 5, 0. Those are our three solutions. And you'll notice that showed up in our list. 4 and 5 were in our list. We just didn't know if they were positive or negative. We could have done the synthetic division for 2 and -2. We would have not gotten 0, and so we would have moved on to the next ones. Okay, so the key here is finding P and Q, finding the factors of the first number and the last number, writing those as a fraction, and then just guessing and checking with synthetic division until we find one, using that solution to factor further. And so now we can factor literally anything. Literally anything. Okay. So we're going to do a few more examples. Some of these are going to have more synthetic division than others. X cubed plus x squared minus 14x minus 24 equals 0. So our first step is take the first number and the last number and divide them using the factors of each. So what numbers multiply to make this, and what numbers multiply to make that. Okay, so I want you to list out P and Q. So X is going to be some of these numbers, and I want you to list them out. Okay, you're going to get plus or minus some fractions, and probably quite a few because 24 can be multiplied a lot of ways. Okay, and I think it's easiest if you go smallest to biggest. You can go biggest to smallest either way, but I think if you use the smallest numbers for your checking synthetic division first, you'll come more quickly to the answers. Okay, so pause the video and then, write out your P and Qs, and then we're going to check them. For this one again, all of the Qs, all the numbers from here are 1. They're all 1. Oh, we can keep using blue. And then we just need the factors of 24. Well, 1 and 24, you can divide 24 by 1. You can divide 24 by 2. It's going to give you 12. You can divide 24 by 3. You can divide 24 by 4. You can divide 24, not by 5. You can divide it by 6, though. Plus or minus 6 over 1. You can divide it by 6, 7, 8. Not 9, not 10, not 11, 12. And lastly, 24. Now, this is a lot of things to check. 1, 2, 3, 4, 5, 6, 7, 8. Positives or negatives for each means there's 16 possible factors or solutions for this polynomial, but only 3 of them are correct. I strongly suggest you don't start at 24. Check 1 first. And then don't forget to double check the negatives because it could be positive 1 or negative 1. So 1 into our synthetic division with coefficients of 1, 1, minus 14, minus 24. So we add, multiply, add, multiply, multiply now, not 0. So it's not 1. Is it negative 1? 1, 1, negative 14, negative 24. So it's the same setup for our synthetic division. The only thing we're changing is the number we're dividing by. We checked the positive version, so now we're going to check the negative version. 1, multiply, we get negative 1, add, we get 0, multiply, we get 0, negative 14, positive 14, we get a negative 10. Not 0, this has a remainder at the end, so our solutions are not 1 and negative 1. That's annoying. So then we just go to our next number. We check 2. 1, 1, negative 14, negative 24. So we just add down 1, multiply 2, get 3, multiply, we get 6. This gives us negative 8. Yep. Negative 16, negative 40. So it's not 2 either. So then we're just going to check negative 2. So we're going to add down, multiply, add down, multiply, add down, multiply, and we get 0. So this is a solution. Negative 2 is a solution, which means we use x plus 2 right? Because putting a negative 2 here for x turns this into 0. So we use the opposite thing. And then we factor with x squared minus an x minus a 12. Okay, so that's our original problem factored. That's our x cubed plus x squared minus 14x minus 24 factored. We factored out the x plus 2. And now we just need to factor this x squared minus x minus 12. So we need, it's a quadratic. You could just keep checking the numbers, but there's no guarantee that it's going to be 3 and 4. It could be 6. It could be 12. It's probably not, but so A is 1, B is -1, C is -12. We need numbers that multiply to make -12, add to make -1. That's going to be 3 and 4, where 4 is the negative number. And so this is x plus 2 times x squared, sorry, not x squared, x plus 2 times x plus 3 times x minus 4. So we use, because a is 1, we use these numbers, and we don't have to use the xbox method. Okay, so that means that our solutions are x equals -2, x equals -3, and x equals 4, which do show up in this list, right? We have a -3 plus or minus 3 here, so it's -3, plus or minus 4, it was positive 4. And that means we also get -2 comma 0, -3 comma 0, and 4 comma 0. So we had to do 1, 2, 3, 4 synthetic division problems before we got to one that had a 0 that was actually a factor. We factored that one out. So it was, we used -2, but that really means that it's x plus 2 we factored out, because -2 turns this to 0. Oh, there's my paper. Turn this to 0. And then the x squared minus x minus 12, we factored that using the xbox method to get these two things. And then that gave us further solutions of -3 and positive 4. I want to do one more example. Yeah. Okay. So first thing, we look at the last constant and the first number here. And we just list out all the possible values of x that will give us 0. And so that's going to be the numbers that multiply to make 60 divided by the numbers that multiply to make the 1 that's in front of this x cubed. Okay, so start with the small ones. Positive or -1, oh, these are all going to be divided by 1 again, but positive or -1. And then we can divide 60 by 2, so positive or -2. And then we can divide 60 by 3. Oh, this should be over 1, plus or minus 3. We can divide 60 by 4. We get 15. Divide 60 by 5, we get 12. Divide 60 by 6. There's going to be a lot of these. Lots of numbers multiply to make 60. Not 7, not 8, not 9, 10. Not 11, but 12. Not 13, 14, but 15. Not 16, 17, 18, 19, but a 20. And then 30 is the next one. And then 60 is the last one. Now you'll notice there's big gaps here at the end and small gaps at the beginning. The strategy here is just assume one works, because it always will. And we'll talk about what to do with fractions that don't have 1 at the bottom next time. But start with 1 and then say, okay, can I divide this number by 2? Can I divide it by 3? Can I divide it by 4? Can I divide it by 5? Can I divide it by 6? And so on and so on. And once you've gotten up a little ways, start reminding yourself, okay, I had to multiply 6 by 10 to get 60. So the next one's 10. And then I had to multiply, then start going back down. I had to multiply 5 by 12 to get to 60. I had to multiply 4 by 15 to get to 60. I had to multiply 3 by 20. I had to multiply 2 by 30, 1 by 60. And eventually you will have done all of the possible factors. Now this is a lot of numbers. There's a lot of synthetic division problems to check. But remember, you only have to find one, and then you can switch to quadratic factoring. Or you can just go through all of them using synthetic division if you want. I'm not going to do that. That's too many synthetic division problems. So we're just going to start with 1. 1 into 1, negative 6, negative 7, and 60. So we add down, we multiply, we add down, multiply, we add down. Not 0. So then we check negative 1. Same stuff. Add down and multiply. We get negative 1, negative 7, makes a positive 7 when we multiply. Sorry. We're going to get 0 when we add these two. 0 here and 60 at the end. That's not negative 1 or positive 1. Then we check 2. 1 times 2, negative 4 times 2 is negative 8. This gives us a negative 15 times 2 is a negative 30, and that gives us a 30. It's not 0 either. One, negative 6, negative 7, and 60. Now, I am not tricking you. There's not a faster way to do this. Algebraically. There's some ways to guess quicker, but not really a faster way to do this. So we're just going to, I mean, at least it's synthetic division and not long division, but there's not a faster way. So we add down, we multiply. This gives us a negative 8. We multiply, we get 16. That gives us a 9. Negative 18. 42. Nope. So then we check 3. 1, negative 6, negative 7, 60. Now, our positive numbers here were 1 gave us 48, 2 gave us 30, and so I'm thinking that 3 will probably turn this to 0, but we'll have to see. 1 times 3, negative 3 times a 3 is negative 9. That gives us a negative 16 times 3. That's negative 48. That gives a 12. That didn't work. So then we check negative 3. Really hoping I didn't make a mistake somewhere. It's possible. So we add down, multiply. add down, multiply. That's going to give us positive 27. Subtract, we get a 20 here, and then multiply by negative 3. Negative 60 gives us a 0. And then we have this will be our quadratic. So negative 3 gives us the expression x plus 3 because we're looking for the 0 value. So this would be x plus 3 times 1x squared minus a 9x plus a 20 equals 0. Now, we've seen this quadratic before. I think it was the other example, unfortunately. But, yeah. So we're going to take this thing and factor it, and that will give us our remaining two solutions. So we need to factor x plus 3 times x squared minus 9x plus a 20 equals 0. Factor this. A is 1, B is negative 9, C is 20. Two numbers that multiply to make 20 and add to make this negative 9 is going to be negative 4 and negative 5. And so we get x plus 3 times x minus a 4 times x minus a 5 equals 0. Because a is 1, we can just use this number and this number in our factorization. That's going to give us x equals negative 3, x equals positive 4, and x equals positive 5. We could have kept going with our synthetic division and checked 4, and that one would have worked. Checked negative 4, that one would not have worked. And checked 5, that one would have worked. There's no guarantee, though, that our solutions are going to be in that first group of numbers. There's no guarantee that our answers are going to be in these first few. It could be that they're at the end here. It's possible. So that's why we check at the beginning. It's more likely it will be in the first numbers, but there's no guarantee. It could be 12 and 15 and 20. Now, probably not that combination because those three numbers all need to multiply to make 60. But it could be 60 and 1 twice, and that would give us the 60 here. So find one factor, then use quadratic factoring or some other method, but likely quadratic factoring, to find our solutions, and then we get our coordinate points. Okay. So next time we're going to do this same thing with values of q that are not 1. In other words, our number here is not going to be 1. And so we're going to get some fraction answers, but also just more synthetic division problems. Okay. So those were our three solutions. Remember, the process is divide the factors to figure out the possible solutions, check with synthetic division, and then once you found one, turn it into a different, easier problem, quadratic factoring, use the Xbox method, and find your solutions. Okay?